You know who discovered black holes? Einstein, or maybe Hawking. You've seen it in 100 videos, but that's not true. Long before either of them, one man already knew the universe could hide invisible stars, stars so heavy that not even light could escape them. He wasn't an astronomer with a giant telescope. He was a country priest with a candle and a quill. In 1783, nearly a century before Einstein was even born. And then, for almost 200 years, almost nobody remembered his name. To understand how that happens, we can't start with him. We have to start with a simpler question. What is a black hole, really? Throw a ball into the air, and it falls back down. Throw it harder, and it flies farther before it drops. Throw it hard enough, about 7 miles every second, and it never comes back at all. It escapes Earth completely. Scientists call that the escape velocity. Every object in the universe has one. The moon's is low, Earth's is higher, the sun's is higher still. The rule is simple. The more mass you pack into a place, the faster you have to move to break free of it. So here's a strange question. What if you kept adding mass? What if you made the escape velocity so enormous that it passed the fastest thing in existence, the speed of light? Then nothing could leave. Not a rocket, not a signal, not even light itself. The object would still be there, still pulling on everything around it, but you would never see it. It would be, for all purposes, an invisible star. Today we call that a black hole. It took Einstein's relativity, a century of physics, and telescopes the size of buildings to take the idea seriously, except someone did the math in the 1700s, with a quill, by candlelight, in a village church. To understand how, first look at where he lived. Yorkshire, England, a small village called Thornhill, a stone church, and its rector, the man in charge of the parish, was named John Michell. By every description, he was easy to overlook. One person who knew him called him a little short man of black complexion and fat. We don't even know what he looked like. Not a single portrait of John Michell survives anywhere in the world. The man who first imagined black holes is quite literally faceless to history. On paper, he was an ordinary country clergyman. He preached sermons. He ran a small parish far from London. And yet, some of the sharpest minds of the 18th century made the journey out to his village just to sit at his table. Benjamin Franklin, Henry Cavendish, who first identified hydrogen, Joseph Priestley, who discovered oxygen. Why would scientists like that travel to the middle of nowhere to visit a parish priest? Because this simple country priest was quietly one of the most underrated minds of his century. Start with earthquakes. In 1755, a catastrophic quake destroyed Lisbon and killed tens of thousands. While much of Europe called it the wrath of God, Michel did something radical. He studied it. He worked out that earthquakes travel as waves moving through the earth, and he even estimated how fast they move. Historians now call him the father of seismology. He didn't stop there. He worked out how magnetic force weakens with distance. He invented a device called the torsion balance, an instrument so precise it was later used to weigh the entire planet, and he was one of the first to point statistics at the night sky. By studying how stars cluster together, he showed they couldn't be scattered by chance alone, that many must be physically bound to one another. He effectively demonstrated that binary star systems are real. Seismology, magnetism, a method to weigh the Earth, binary stars, all from one man in one small village. But his strangest idea, the one that was 2 centuries ahead of its time, came on a single day, November 27th, 1783. The day John Michell stood up in front of the Royal Society in London and described something almost nobody would take seriously again for 200 years. Michell started with the science of his time, Isaac Newton's idea that light is made of tiny particles. If light is particles, Michell reasoned, then gravity should pull on them, just like it pulls on everything else. Gravity should be able to slow light down. So he asked a question no one had seriously asked before. How big would a star have to be before its gravity could stop light from leaving at all? And then he actually calculated it. He worked out that a star with the same density as our sun, but more than 500 times wider, would have an escape velocity greater than the speed of light. Its own light would fall back into it. From the outside, it would simply vanish. He called these objects dark stars. Sit with that for a moment. In 1783, with pen and paper, a village priest described a star so massive that light can't escape it. That's the core idea we now call a black hole. Here's the part that still surprises physicists today. When you compare the minimum size Michell calculated to the modern figure for a black hole's edge, what we now call the Schwarzschild radius, the two numbers land remarkably close, considering he was using completely the wrong model of light and gravity. He got roughly the right answer with the wrong physics over a century early, but he didn't stop at "they're invisible." What he proposed next is almost harder to believe. Michell had an obvious problem. If a dark star is invisible, how could anyone ever find one? His answer, in 1783, was ahead of its time. Look for its gravity. If a dark star had a normal, glowing star orbiting near it, you'd see that bright star swinging around. Nothing. An empty patch of sky. The motion of the visible companion would give the invisible giant away. That's close to how astronomers actually find black holes today. We watch stars orbiting an unseen mass at the center of our galaxy and infer what we can't see from what we can. Michell described the logic of the method 2 centuries before anyone had the instruments to use it. He even suggested you might detect a star's gravity acting on its own light using a prism, an early, imperfect sketch of what we now call gravitational redshift, not confirmed until the 20th century. The detection method, the redshift, the invisible giant hiding in plain sight. Again and again, a country priest in 1783 pointed in exactly the right direction. Not perfectly, but recognizably. There was one place, though, where his reasoning broke, and that break is part of why his idea nearly vanished. Michell's error was built into his starting assumption. He believed gravity slows light down over distance, that light leaves a star fast and gradually loses speed the way a stone thrown upwards slows as it climbs. But light doesn't work that way. Its speed in a vacuum is constant. Einstein would formalize why in 1905, Michell's specific method, inferring a star's mass from how much its light supposedly slowed, simply couldn't work. His core conclusion still held: a sufficiently massive object really would be invisible. But not long after, the scientific consensus shifted again. Physicists increasingly treated light as a wave, not a particle, and under a wave model, it wasn't obvious how gravity could act on light at all. Michell's dark stars no longer fit the accepted picture. Without a framework to support them, they quietly stopped being discussed. He wasn't alone in that. In 1796, the French mathematician Pierre-Simon Laplace proposed something similar, independently, and later editions of his own work dropped the idea too, as the same shift in thinking about light took hold across the field. John Michell died in 1793, in the same quiet village, his boldest idea already fading from view. It would sit in the pages of an old journal for close to 2 centuries. Then, decades later, someone went looking. The path back was long. In 1915, Albert Einstein published General Relativity, rewriting gravity itself. A year later, Carl Schwarzschild used Einstein's equations to describe the boundary of a region so dense that nothing could escape. Decades on, Robert Oppenheimer showed how a dying star could actually collapse into one. And in 1967, the physicist John Wheeler popularized the name that finally stuck: the black hole. It was in the 1970s, as historians of science dug back through old archives, that a paper read to the Royal Society in 1783 resurfaced. And they realized a country parson had reasoned his way to the core idea more than a century before Einstein ever published a word on gravity. The American Physical Society later put it well. Michell, they wrote, was born under a dark star and never quite reached the escape velocity to break out of Thornhill. So, who really came up with the idea of a black hole? Not Einstein, not Hawking. The first person to work it out on paper was a faceless country priest writing by candlelight in a village most people have never heard of. He was right, using tools far too crude for the job, a full century before anyone else got there. His idea didn't disappear because it was wrong. It disappeared because the physics of his era briefly moved somewhere that couldn't support it, and by the time the field caught up, everyone had simply moved on without him. That's worth sitting with. Being right isn't always enough. Sometimes an idea also needs the rest of the field to be standing in the right place to catch it, which leaves one quiet, uncomfortable thought. How many right ideas are we walking past right now? Tonight, look up. Somewhere out there is an invisible star, a point of pure darkness we still don't fully understand, and the first person to imagine it did so with nothing but a quill, a candle, and a mind working a century ahead of the tools that would eventually prove him right. We still don't know his face. His name was John Michell. If this one got to you, subscribe. There are more overlooked minds worth bringing back.